relationship is present. And like I alluded to earlier, it is with residual plots. So that's how we determine whether a linear relationship is present or not. So a residual plot might look something like one of these. So how do we actually interpret a residual plot? And again, they exist to test the assumption of linearity. So if we're constructing a residual plot, our goal is to figure out if a linear relationship is present. The most important thing to remember, or like the handiest way that it kind of sticks in my brain how I remember it, is if it's non-random, then it's non-linear. But if it's linear, the points will be randomly scattered above and below the line. So I'll show you what I mean here. So here, our data points are not random. There's actually like a pattern going on there. And that's kind of like the goal of a residual plot. It kind of zooms in to see if there's any underlying trends or patterns that we kind of couldn't see in the original scatter plot. And that's what's happened here. We've plotted all our values on the residual plot, and I won't go into now how to calculate the residuals and all of that. That's something you could do some practice questions on a little bit later if you'd like to rehearse that knowledge. But because we can see here, our points aren't randomly scattered. There's actually a really clear pattern going on here. That's what I meant earlier about how non-random means non-linear. So if I come back to our next slide again, this is non-random. Therefore, from this residual plot, I would conclude that this relationship is non-linear. Whereas this one, we can see that our residual points are randomly scattered above and below the line. So it's super random. So this tells me that there is a linear relationship present. So when interpreting residual plots, non-random means non-linear, and randomly scattered around, yes, it is linear. So that's just a little clarification on residual plots. And again, least squares regression lines. You can also calculate the A and B values using your calculator. It's almost the exact same process as doing it with your R value. I've got the steps up on the screen here. It's mode 2, enter your values, press on, shift 1, 5. Then you press 1, which will correspond to A if you're wanting to find out the A value, which is the y-intercept, or you press 2 if you're wanting to find out B, which is your gradient or your slope. And another word of caution here is it's important to make sure that you've got your X, what you've classed as your X values consistent and your Y values consistent. Because if you flipped your X and your Y values, you would get different variables. So that's why it's important to identify what's your explanatory variable and what's your response variable right at the start. And like I touched on earlier, association does not mean causation. When we're talking about scatter plots, we're talking about correlations, we're talking about associations, but we cannot discern causation from that. There's lots of different things it could be. It could be the common response, confounding variables, or sometimes a coincidence. So that's just another word of caution there. Whenever we're talking about all of this, we're talking about association and correlation, not causation, because there could always be kind of underlying factors or other variables that are kind of influencing our data that might not be obvious at